Very good evening. First of all, just I introduce about the KhetiValah, connecting farmers to farm teams, connecting farmers to for the increasing the productivity as well as the production of the different types of the crops by the farmers throughout India. And today here we connected in KV Dialogue 18, dealing with a climate change in Indian agriculture. So today with us, Dr. C.A. Rama, Principal Scientist, Agriculture Economics, ICAR-CRIDA, Hyderabad. So first of all, welcome to you, sir. So who we are? KhetiValah is the app providing the information to the farmers with right guidance and the financial assistance for a visionary investors who are passionate about the farming. So here the KhetiValah app is easy to install in the mobile phone, Android phone, and to download it, install it, and to get the latest information about the agricultural point of view. As a gesture of gratitude to farmers who work tireless to ensure food to the population, so we launched KhetiValah, a farmer-friendly app that supports a farmer journey to progress. So we know the farmers need a proper guidance. We know about that. The farmers required a proper cultivation guidance, input required material guidance, and the selling of their product into the market. So for all of the point, the farmer need a knowledge to produce their crop and get them more profit. So KhetiValah is helpful that point of to the farmers. So this app all in one solution connect the different cities in our country, connecting to the farmer to the niveshakas, helping the farmers to get a financial support in the farming, assistant farmers in helping them to produce required materials for the farmings like the input seeds, fertilizers, providing farmers with farming doctors that helps the farmer take the precaution at early stage of field in the crop production, providing other farmers who own large farming space with service working through this app, reduce the financial burden on the farmers. So this app in all-in-one solution, farmers gets advanced knowledge in a single app. So how we do giving back to the farming community is our central objective. Our farming features and activities are streamlined under the Kheti Corner, Kheti Kendra, Kheti Puraskar, Kheti Samiti, Kheti Kosha, KV Dialogue, KhetiValah 24/7 Agri News YouTube channel, Kheti Kalyan, and Kheti Corner. So now one by one here we discuss about the initiatives by the KhetiValahs. Kheti Corner offers a seamless platform for the farmers to sell their produce directly to the consumers, cutting out the middleman and ensuring the fresher produce for the customers. So directly the money after selling their product goes down into the pocket of the farmers. So just we cutting here the middleman. Kheti Puraskar. Kheti Puraskar is recognition of the people in the field of agriculture. This aims to promote the agriculture by recognizing the talent and initiatives. Some of the farmers, scientists, they're working in the field of agriculture and they do a innovative research, they develop a innovative technology. So such type of technologies are grateful towards the farmers. So that's why the KhetiValah identify the such people in the society and they give a Kheti Puraskar to such people. Kheti Kendras is a setup at selected the mandals where the farmers can get the valuable insights on a modern practices, receiving the guidance and latest tech knowledge and more. So Kheti Kendra is the corner where the farmer gets the latest technology to the people those who are in the person having the great knowledge in the field of agriculture. So they provide the knowledge to the farmers. Kheti Samiti highlights agriculture machinery manufacturing companies focusing on those involved in the production of agriculture machinery and organic farming. So we know about that. The present the government focusing on organic farming, natural farming, zero budget farming. So Kheti Samiti play a vital role into providing or the just utilization of more amount of the machineries, more the equipments to because we have shortage of the labor and towards motivate the farmers for organic farming. Kheti Kalyan is a platform for the farmers and the Niveshakas organized by the KhetiValah to bring both the farmers and Niveshaka on one stage or one line. KV Dialogues. Right now we are in this phase, KV Dialogues. Every week we conduct a dialogue, a training session or the work session for the farmers. And here the technical person, they present on one subject on every week. In this session, farmers can join and ask the question to our the guest or the speaker in the KV dialogues. KhetiValah having 8 languages KV dialogue presently now and much more in upcoming days. So KV dialogue is a series of presentation and the workshop where the farmers can learn more from in industry experts and ask any questions they may have. So KhetiValah 24/7 Agri News YouTube channel. KhetiValah Agri News delivers the expert analysis and the commentary from the leading voices in the field of agriculture industry on the key issues through its monthly magazine and YouTube channel. Kheti Kosha helps the landowners lease their land where the small farmers with no land can practice farming, enabling an income stream for both. So we know about that some of the NRIs, they are having the land in our country and they are not utilized. So in Kheti Kosha, KhetiValah helps to the farmer providing such land for the cultivation of the agriculture practices. So this is about the initiatives taken by the KhetiValah. Third party services also provided to the farmers by the KhetiValah farming and fertilizers, pesticides, bios and auction, machinery spare part, guidance and support, finance, marketing place and support, insurance, farming, farmers training, seeds and crops. So KV Dialogues is a valuable insight on various agriculture aspects. Every week on 6:30, we conduct the KV Dialogue on the different topics on each and every month. So talk subject by the subject matter specialists, inspiring accountability and the innovation. Specialists from the agri-tech companies, professional and the farmers, collaboration and the gathering crucial feedback. So I am Dr. Dhananjay. I am currently working as assistant professor at Amity Institute of Organic Agriculture, Amity University. I am moderator of today's session. So KhetiValah magazine is a magazine monthly published having the great and advanced knowledge to the farmers, innovative research by the scientists, and the thoughts for the farmers for upliftment of doubling the farmers' income. So, want to sell our farm produce, say by the middleman, and sell directly to the consumers. So, these are the previous panel speaker of the KV dialogues from ISRO, capital investment, from the different state agriculture universities, panel speaker by the KV dialogues in from different type, different state, different campuses, Lucknow campus, Amity Lucknow campus, Nashik from Maharashtra. Then here we're talking about sustainability consultant. This is a KV dialogue in different languages. We also have done. This is Marathi KV dialogue, and today we are in the KV dialogue 18 on dealing with climate change in Indian agriculture. So we know about that climate change happen at every place. So the irregularity of rainfall, scarcity of the water, the farmer are facing lot of issues, then attack, disease and pest more attack on the crops. So our farmer, they're facing lot of issues due to the climate change, and their produce is not produced, their product is not much more yield, right? So that's why we need a mitigation practices, we need a modern cultivator practices, we also adopt the ancient culture practices. So now today with us Dr. C.A. Rama, principal scientist, agriculture economics, ICAR-CRIDA, CRIDA, Hyderabad. So now I request to our today's speaker, come on the desk. Over to you, sir, and please share your valuable thoughts with us in our today's the audience.
Thank you, Dr. Dhananjay. Very interesting to know things about KhetiValah and compliments to your organization for the effort that you are making for the welfare of the farmers. Actually, when I was contacted about this KV dialogue, I was told that there will be mix of audience, both students, farmers, and other academicians, mix of audience. So accordingly, I prepared a lecture on this that I want to share. It have both some kind of academic content and also something that is useful for farmers and also something that is useful for other stakeholders. I just, because I thought there is the students here, I thought I will start with some terminology in the context of climate change. We hear a lot about weather and climate. So they are actually different. Weather is a kind of short-term phenomenon. Like weather describes atmospheric conditions at a particular place. What is today's weather in Hyderabad? What is today's weather in Delhi? So both it refers to a particular day and place. That is what weather is. And climate is actually kind of expected weather. Kind of what generally we say that winters in Delhi are very cold. Similarly, winters in Hyderabad are not so cold as they are in Delhi. Or winters in southern India are much hotter compared to northern India. And Rajasthan has both extreme winter and extreme summers. So that is kind of climate. And then in that case, we don't refer to it as weather. We refer to it as climate. So typically, climate is what we expect and what Weather is what you get. That is what the main difference between. And also, when you talk about climate change and when you read about climate change, these two terms, other two terms are climate variability and climate change. These two terms are very frequently used, and we need to differentiate what they mean. So, basically, climate variability is a kind of transient variability. Today, this year there will be drought, next year there will be flood. And this variability doesn't persist over decades. Maybe for 10, 15 years that may persist, but the long-term mean climate will not change. Suppose, for example, if you want to give an example, if you take a look at the weather climate of Saurashtra, last 15, 20 years, the rainfall is very high compared to the historical average. But we don't know whether this higher rainfall is going to persist for the next 20, 30 years. If it is going to persist for the next 20 to 30 years, then we call it as a climate change. Otherwise, again, if it comes back to what used to happen before 15, 20 years ago, then it's only climate variability. So in climate variability is a kind of transient variation, temporary variation, and climate change is a kind of permanent shift in the expected climate. So that lasts for decades together, 60, 70, 80 years. That is what climate change and climate variability are. And for the benefit of students, how this climate change happens. So climate change is basically about warmer climate. We know that the climate is in April very hot now already. The last 15, 20 years are much hotter compared to the last 200 years. So what happens actually is typically a kind of greenhouse effect. So what happens is when we call something as greenhouse effect is the sun rays from sun comes to the earth. Some of it goes back, some of it gets trapped because of these greenhouse gases. Greenhouse gases are like carbon dioxide, methane, all this. So when that gas is trapped within the atmosphere, then that leads to actually warming of the globe or earth. This is what is referred to as greenhouse gas effect, global warming. We can see here the solar radiation, incoming solar radiation here. The radiation comes here, some part of it reflects back, but some part of it actually captured. It's trapped in the atmosphere and troposphere. That leads to warming of the earth. So these are actually greenhouse gas, carbon dioxide, nitrous oxide, methane. Carbon dioxide, plants take carbon dioxide, emit, and nitrous oxide, that comes from actually rice cultivation. Methane, again, it comes from rice cultivation and also livestock consumption. And these CFCs, they're basically refrigerating gases. So this is what the different gases are and how they are emitted from where they come from. So carbon dioxide, combustion of solid waste, fossil fuel, petrol, all this automobile industry, burning of wood and wood products. Methane basically it comes from transport of coal, natural gas. Also, it comes from livestock because enteric bacteria releases methane in the guts of livestock, and they ruminate. Those are emitted. Nitrous oxide typically comes from fertilizer use and solid waste and fossil fuels also. And this fluorocarbon, different types of fluorocarbon, they come from industrial processes. And when this gas released into the atmosphere, so they lead to global warming. The carbon dioxide is actually the standard. With respect to that one, the global warming potential of different gases is, you can see here, methane is 21 times in terms of its global warming potential compared to carbon dioxide. Nitrous oxide is 310 times. All these fluorocarbon, you can see the numbers here. So they are much more powerful, much more potent in terms of warming the planet. And the other two terms, when I say dealing with climate change, that refers to climate action. So climate action has to be principally two kinds of responses to climate change. One is mitigation, the other is adaptation. Mitigation is actually, as I said, this climate change happens because of higher emissions of global greenhouse gases, what are typically abbreviated as GHGs. So in order to reduce or slow down climate change or global warming, we have to reduce the emissions of those gases. That means mitigation is preventive in nature. That means we are trying to reduce the emission of greenhouse gases. But the problem with this is actually the benefits of any mitigation action are felt in the long term. So whatever you do today, the benefits of those mitigation actions will be felt only after 20, 30 years. That is the problem with the mitigation. But another advantage with mitigation is wherever mitigation action happens, everybody gets benefit. Suppose if you are taking mitigation actions like you are going forest growing trees, capturing carbon dioxide, all that. If you do it in Australia, if you do it in America, if you do it in India, if you do it in Africa, the whole earth gets benefit. That's why they are referred to as global public goods. The mitigation benefits are global public goods. And effects are certain. If you grow a tree, it captures carbon dioxide. That is certain. That's why you can measure those reduction in the greenhouse gas emissions. That's why easy to monitor. But unlike mitigation, adaptation is a kind of responsive or adjustment. So if you see that globe is getting warmed, temperatures are rising, rainfall patterns are changing, then we react. As farmers react, other citizens react in different ways. That means that is referred to as adaptation. But the advantage is that the benefit to the implementer of adaptation is immediate or short term. Suppose I, as a farmer, suppose I see that drought is going to happen next year. I choose a crop variety which is tolerant to drought. So when there is a drought, this variety being drought tolerant will not be affected in terms of yield loss. So that means I get the benefit as a farmer, I get the benefit immediately at the end of the season of the crop, when the crop is harvested. So benefits from adaptation are immediate or short run. But the disadvantage, unlike mitigation, is the only where the adaptation actions are implemented, only they get benefits. Suppose if India is taking some adaptation option, only India will get benefit, not the America or not the Australia. Similarly, Australia takes some adaptation benefit, they get benefit, we don't get benefit. That's why they are called regional public goods or local. So because the benefits are local, but the effects are not so certain. So if you take a drought tolerant variety, it may also happen that the drought is so severe that even a tolerant variety may not give good yield. So there is some kind of uncertainty there in terms of adaptation, which is why it is difficult to monitor. So we have to remember these differences because if you want to understand the international support, global support to adaptation options or mitigation options in developing countries, this is the reason. Because global, if you look at if you are following the discussions in the UNFCCC, so there, the developed countries, they are more interested to invest in mitigation, not in adaptation. The reason is that wherever the mitigation actions happen, whole globe will get benefit. Suppose they are supporting mitigation action in India, even the US will benefit, Australia will benefit, Canada will benefit, everyone will get benefit. That's why they are willing to support mitigation actions in India or other developing countries like African countries and all those. But they are not so willing to support adaptation because even if they give money for our adaptation, only we get benefit, they don't get benefit. And if you want to talk about climate change at the world level, you can see the World Risk Index. You can see the dark red color is India, where the climate risk is very high. That's why we have to invest in to take efforts to reduce the impacts of climate change. But one of the reasons here is that high population, because you can see here China and India, though on per capita basis, we are not very high, but because of the population is very high, that is leading to high climate risk. Similarly, global hunger. You can see here global hunger index is very high for India. This percentile coverage, you can see about 25 to 35% of population is affected in terms of global hunger. You can see the numbers on the right hand side. So India is not very well placed in terms of global hunger index. About 190 million people, that is less than 14% of population is undernourished. 20% of children under 5 are underweight, and 35% children under 5 are stunted. So similarly, more than half of the women are the reproductive phase are anemic. So these numbers are not so attractive. Though we are claiming that we are world's fifth largest economy, still we are still a long way to go in terms of addressing some of these development deficits. If you look at Indian economy, agriculture and climate change, if you put the context, India is one of the economies which are growing very fast in the globe. Now around 7 to 8% we are projected to grow. So no other country in the world, especially after COVID pandemic, no other country is growing at that rate. But if you look at what happened over the last 7-8 decades since independence, there was tremendous increase in the production of many agricultural commodities like food grains, milk, fruits, vegetables, cotton. Multiple times they increased. But there is also decline in the share of agriculture in the gross value added. Something like GDP here, but not so in the employment. So at the time of independence, our GDP more than 70% of our GDP is coming from agriculture. At the same time, 70 to 80% of population is dependent on agriculture in terms of employment. But currently, it's only 15% of GDP is coming from agriculture, but still nearly 50% of people are dependent on agriculture employment. This is the crux of the problem in agriculture. That means 50% of people are sharing 50% of the GDP, and other 50% of people are sharing 85% of GDP. You can see the kind of inequity between those people who are dependent on agriculture and other secondary and tertiary sectors. So the profitability of agriculture actually declined tremendously over these 60, 70 years. And we are world's largest populous country, 1.4 billion population. But at the same time, we are 140 million farmers, 600,000 villages, 700 districts, 29 states. You can see the enormity of the challenge of climate change adaptation. And we all know that sustainable agriculture is critical to food and livelihood security and also for increased agricultural growth. And you say that 50% of people are dependent on agriculture and they are not witnessing the growth, there is no way that we can achieve inclusive growth. So growth in agriculture is very, very critical to if you want to achieve inclusive and sustainable growth. Climate change, one of the potent threats. There are already other threats to global, like changing market environment, land degradation, there are groundwater availability. There are other threats, labor availability. All these threats are there, but climate change is one of the potent threats to sustainable agriculture. But if you come to agriculture more specifically, again, if you want me to highlight two problems of Indian agriculture, 2 or 3 problems of agriculture. One is small size of holdings. 86% of holdings are less than 2 hectares size. And the monsoon dependency. We get rainfall during June to September, southwest monsoon. After that, it's kind of dry period, leaving some pockets like Tamil Nadu where the northeast monsoon is also there. But another challenge is diversity. Diversity in both agroclimatic settings and also socioeconomic settings. We have regions in Rajasthan where the rainfall is 150 mm in annual rainfall. We also have northeastern part of the country where we get 4,000, 5,000, 15,000 rainfall is also there. So that kind of diversity, we have very desert climate in Rajasthan, very subhumid and perihumid climate in some parts of Kerala and northeast. So huge diversity. So this is very much challenge both in terms of climate adaptation planning as well as development planning also. And India is signatory to United Nations Framework Convention on Climate Change. So we have to commit. We committed already to mitigation also. We said that we will be achieving net zero economy by 2070. And also adaptation is our own need. Though mitigation is important, but adaptation is more important for us because, as I said, many of we still have to address development deficits like poverty, undernutrition, and malnutrition. So those things are very, very important. So either you have to work on both, or we have to work more on adaptation. That's why now I think everybody is talking about climate change, starting from top level, global level policymakers to normal citizens. And if you look at climate change in India, world, you can see that the global mean temperature increased by 0.6 to 0.7 degrees between 1950 to 2010. And most of it is actually attributed to human activity. That is actually UNDP, United Nations Development Program, differentiates climate change into 2 parts. One is natural variability, the other is human-induced. Because that human-induced part is because of human actions, our own actions. And it impacts, the climate change impacts all global hydrological systems, ecosystem, crop production, sea level, everything, everywhere will be affected. But another issue is that impact is inequitable. Developed countries will be less impacted, and developing countries, especially those near to the equator, they will be impacted more. But the problem is, again, who are responsible for the climate change historically? Again, developed countries. They are kind of responsible for climate change. But developing countries like us, India, African countries, they are actually suffering. But what can we expect in terms of crop production or food system production? What are the implications for temperature rise? So if the temperature is increasing by 1 degree, especially there will be some increase in the crop yields, especially in the temperate regions like Canada, Greeceland. So which are the countries which are near to polar region, Switzerland, this kind of countries, because of higher temperature, some crop may increase yields. But if you start the temperature, average temperature increases by more than 2 degrees centigrade, the crop yields, especially in tropics, will decrease significantly. You can see that the temperature of 4 degrees, 5 degrees increase. Actually, we cannot even imagine. Probably when the temperature increases by more than 5 degrees centigrade, probably we don't have to bother about that situation because we will not be existing at that levels of temperature rise. No human can exist at that. If you come to the Indian scenario, what happens? So this is actually what has been happening in India for the last 20, 25 years. You can see every year there is a climate extreme events. You can see the 1 year floods, droughts, heat wave, cloud wave. You can see if you talk about droughts, 2001 to 2009, 2012, 15, these are very prominent droughts in the country. Similarly, there are also heat waves in 2003. That was a very prominent heat wave. You can see 2009, there is a drought again. In one pocket of the country or the other pocket, there is always some flood or some drought. So there are actually, if you ask me, there are two typical phenomena associated with climate change. One is this frequency, increased frequency and intensity of extreme events. The other is gradual changes in temperature and also sea level rise. So these are the two kinds of changes that are associated with climate change. But as I said, the climate change is global, but climate adaptation is local. So if you, there is already evidence there. If you look at climate at the district level, you all know that district is an administrative unit for India, where most of the development planning and also resource allocation in terms of budget allocation is taking place. Both you know that the Planning Commission or Niti Aayog identified aspirational districts or underdeveloped districts. Similarly, both at the state level and at the country level. So district is the development unit, administrative unit at which most of the development planning is taking place in India. That's why what we tried is that whether there's evidence so that climate change is already happening. You can see at the top left here, first two maps. You can look at the climate based on the data, climate data for 1901 to 50, and the right hand is 1971 to 2005. You can see some of the regions which are arid, they're becoming semi-arid. Some of the regions which are semi-arid, they are becoming arid, and also some humid. There are a lot of changes in this. They have actually implications, you know. Now there are no programs like DPAP. Everything is coupled into Pradhan Mantri Krishi Sinchai Yojana. But there used to be programs called DPAP, Drought Prone Area Program, also DDP, Desert Development Programs. So for those development programs, the eligibility of a district is based on one of the criteria is kind of climate classification. So the climate of the district is arid, semi-arid, some humid. You can see now the eligibility of those districts will change if you want to apply those same rules into this condition. But there is another problem that these programs are subsumed into Pradhan Mantri Krishi Sinchai Yojana. And also, if you look at the projections, also you can see how the rainfall is going to change, how the temperature is going to change in the different districts of the country, how the drought is going to change, how the extreme rainfall, especially rainfall in the heat wave. You can see increasing. Only one advantage here with projection is the rainfall is annual on the annual scale. The rainfall is going to increase. This is one positive point of climate change. But the distribution is going to change. So we know more. There may be variation in the southwest monsoon, in the northeast monsoon, and summer rainfall. Distribution of rainfall is going to change. But one unique feature, one is more certain, is that what we are already experiencing is that increasingly warmer climate. So even the climate, this is another set of projections. You can see for South Asia as a whole, you can see the rainfall is the top panel is rainfall changes. So for different climate scenarios, the rainfall is going to increase. Similarly, for maximum temperature and minimum temperature, this is for South Asia. India, Pakistan, Bangladesh, Nepal, Sri Lanka, these are the countries. So you can see the change in temperature. You can see the scale is on the right hand side. You can see up more than 4 degrees centigrade change in temperature, maximum temperature. Similarly, minimum temperature also more than 4 degrees centigrade. It's likely to happen by the end of the century. So we have to be very careful. We have to do a lot more serious work on mitigation as well. So we don't have many decades left for us as I said, showing the previous slide, any rise in the temperature more than 4 or 5 degrees centigrade. So that is going to be catastrophic, and humankind may actually exist also. If you look at the climate change impacts, especially for India, there are a lot of studies. One is there is one study which says that pure carbon fertilization. Before telling this, I will just tell two sentences on what is carbon fertilization effect. You know that climate change or global warming is happening because of the increasing levels of carbon dioxide in the atmosphere. And carbon dioxide is what is required for photosynthesis of plants. So there will be a positive effect of higher carbon dioxide levels in the atmosphere. So if there is no carbon fertilization, that is actually beneficial to the croplands. If there is no carbon fertilization effect, assuming it's not there, so the rice yield will decrease by 15 degrees centigrade, 15% rice yields. When there is 2.5 degrees centigrade rises the temperature. When the temperature increases to 4.9 degrees, so the rice yield will decrease by almost 5%. Similarly, wheat yield, they will decrease by 25%. You see, so wheat is typically grown during winter. So when the temperature is increasing there, the crop is more sensitive. So the wheat yields will decrease by 25% for a 2.5 increase degrees centigrade temperature. And that the decrease will go up to 42% when the temperature rises to 4.9 degrees centigrade. But if you assume there will be some level of carbon fertilization effect, so the change of 2 degrees centigrade in temperature and 7% change in rainfall. Expression is rainfall. GDP from agriculture will decrease by 7%. Similarly, the temperature is rising by 3.5 degrees centigrade and rainfall is increasing by 15%. Then GDP will decrease by 25%. This will lead to higher poverty and higher hunger. So there are also likely effects on per capita consumption of calories, because those are the indicators of food security or nutrition security. You can see the calorie consumption per capita will decrease by 18 to 21% in different modes. These are actually GFDL, GIS. There are different climate models which will lead to different climate projections, but these models are updated now. But still, they will give a sense of probable changes in terms of what can happen for different development indicators like per capita calorie consumption, and also population proportion. In the bottom, this is kind of poverty indicators, expenditure prices. This will increase to from 0.183 to 0.283, 0.20. So the proportion of population at the lower expenditure prices will increase. And climate change will increase because food security also. And food security has 4 typical dimensions. When we talk of food security, we will be talking about food availability, food access. Even though there is no available, production is there. Food availability is kind of broadly can be linked to food production like rice production, wheat production, millet production of pulses like pigeon pea, chickpea kind of things, and also livestock and fish production. Access is actually that should be available in the market, and farmers should, consumers should have money to buy that. So that means the prices should be available, should be accessible, affordable. And utilization, that means even if you are eating food, if your health is not good, so you are not able to utilize it. And also stability. So that means I should not be bothered about whether I can buy food for the next day or next week or next month. So there should be stability in both availability, purchasing power, and also utilization, your health. So these are the 4 dimensions of food security, and climate change affects all these 4 dimensions in different ways. And also climate change also affects the nutrition parts, both soil nutrition, plant nutrition, and also human nutrition. So there are studies which show that elevated CO2 level, CO2 is carbon dioxide, with accumulation of soluble sugars and antioxidants. That is one good sign, but reduce protein, nitrate, iron, zinc, and magnesium in plants and grains. So that is actually worrisome. That means you have to, if you want to take a certain level of say 10 grams of protein, you have to consume more of that particular product. There will be 3% loss in nutrients in crops such as rice, maize, barley, soybean, potato, and vegetables. So that is kind of worrisome thing. And global per capita nutrient availability of protein, iron, zinc projected to decrease by up to 20% reduction will be there in availability. That's actually, again, worrisome fact. Effects on crop phenology can negatively affect quality. Crop phenology, first, which is the time taken from crop sowing to crop maturity, when you harvest the grain. There will be different stages like vegetative phase, reproductive phase of the crop, and maturity phase. So the time taken to reach these phenology different crop stages will actually be shortened because of high temperatures. So when the temperature is high, actually crop duration will be shortened. In that case, actually the development part of the crop will be affected, and so that also affects crop grain quality, plant quality. Another thing is that untimely rains affect quality. We are seeing just last week we saw in Telangana there was untimely rains. The rice was harvested, it was actually spoiled. It was lying on the immediately after harvest, it was lying in the open. So again, it gets spoiled. It affects quality. There will be a lot of more choppy grain. Storage life will be affected. More wastage, and then when the grain is spoiled, actually farmers, both quantity loss will be there, quality loss will be there. Farmers won't get reasonable prices. Again, farmers' income will be lost. And also, changing temperature regimes. When you are exposed to hot sun, very hot temperature, it will lead to health effects on both also human beings also. So the projections, health studies actually say that the disease incidence on human beings will increase. The kinds of malaria kind of diseases will also increase. So, and also you see that whenever there is a flood, there will be a lot of health effects in human beings because of other communicable diseases will increase because of a flood. So these are health hazards that are associated with climate change. And climate changes labor productivity also. When you are exposed to hot sun, it's not so easy to work as efficiently as in mildly wet climate. So there are some studies actually climate change vulnerability also is associated with malnutrition. We will not go into those details. The message of this is actually children residing in districts with climate change vulnerability are likely to have malnutrition compared to the districts with climate change, while the vulnerability is low. And similarly, districts in the districts surrounding the high vulnerable districts, they're also some kind of more likely to have problems like stunting, wasting, anemia, underweight, all these things. There is another study which showed that, especially in Odisha, there are studies which showed that households who are affected by flooding, the incidence of stunting, underweight, and wasting is more compared to those households that are not affected by flooding. Other studies, I will come to this slide at a later point of time. But climate, when it comes to agriculture, climate change is also not only culprit, but agriculture is also culprit in terms of leading to emissions. Though agriculture is affected by increasing higher emissions, but agriculture as a sector, both when I say agriculture, it includes both crop production, horticulture crops, livestock, fish, everything. So don't be misled by when somebody refers to agriculture. Agriculture includes all this. It is not only limited to crop production. Unfortunately, there are many people who are using agriculture to mean just crop production, but by definition, it's not so. So agriculture includes everything, both production of crops like rice, wheat, millets, and all these things. Horticultural crops like mango, fruit, all fruits, all vegetables, livestock, and fisheries. This is the point I think one should make note because for people like me who are coming from agriculture education, so it is painful to reduce agriculture to only crop production. It's not really so. Agriculture is leading to also emissions. Both agriculture and climate change, they share a two-way relationship. One will affect the other. And I will come to the what is India doing, some broader large-scale initiative by government in terms of what government of India is doing to deal with climate change. As you know, the action started in 2007 or 2008 when the Prime Minister National Action Plan on Climate Change is actually institutionalized. So this is actually this is referred to as NAPCC, National Action Plan on Climate Change. So this is chaired by the Prime Minister of India, and it has actually 8 missions, which are actually dealing with both the mitigation and adaptation. So some missions are actually have focus on mitigation. Some missions are having focus on adaptation. and some have actually both mitigation and adaptation component. If you look at the National Solar Mission, actually, that is actually mitigation focused mission, where we are trying to increase solar power, production and utilization of solar power. So basically, the aim is to reduce the dependence on fossil fuels like petrol and diesel, so that our emissions will come down. So naturally, the focus is on mitigation. And the National Mission for Green India, this is again another mission which has relatively more focus on mitigation, like more forestry, afforestation. This is another mission. National Mission for Sustaining Himalayan Ecosystem. This is another mission where we are more focused on securing Himalayan ecosystems, because they are very fragile ecosystems. What happens in Himalayas actually has huge implications for regions like Punjab, Haryana, Rajasthan, Uttar Pradesh. So because though most of the river systems are fed by Himalayas. So here the focus is again both on mitigation as well as adaptation. So what is more closely related to is you can see at the bottom this one, National Mission on Sustainable Agriculture. So this mission has exclusive focus on agriculture in terms of both, though the focus is more on adaptation and resilience, but there are certain aspects which are also helpful in mitigation. Similarly, National Water Mission, which is also has some implications for agriculture, because water is very critical for agriculture, water availability, irrigation. So they are very, very critical to what happens in agriculture. So these two missions are very, very closely related to, though other missions also have implications for agriculture. Like solar mission, we have project Kusum, where we are trying to use the energy, solar energy in agriculture. So there are different components of this National Mission on Sustainable Agriculture, which is more popular as NMSA. One component is rainfed area development, where you know that Indian agriculture is, as I already said, monsoon dependent. Only 50% of agriculture has some access to irrigation. The rest 50%, half of the agriculture that's on area doesn't have any access to agriculture. So there is a special focus on rainfed area development, and there is submission agroforestry. Agroforestry is very important because the beauty of this is actually this is both a mitigation intervention as well as an adaptation intervention. By growing more trees, we are contributing to mitigation. But when we are combining with agriculture, because there is a microclimate modification component in agroforestry, so that will actually reduce the temperature of the croplands, ambient climate for the crop. So that will better actually save the arable crops also. That will also actually kind of smoothing income fluctuations also, because you're also getting some income from the tree component of agriculture, right? So that's why it's also it has both agroforestry. Agroforestry has both adaptation and as well as mitigation component. As National Bamboo Mission, another actually both it has mitigation because bamboo is a tree. It captures carbon, sequesters carbon. It also it leads to more incomes. And also soil health mission. Many of us know about soil health cards. So lakhs of farmers are given soil health cards, which is there is some evidence that that is leading to reduced use of nitrogen fertilizer, which is actually have both mitigation benefit as well as in terms of adaptation. It is helping in terms of reduction in fertilizer use. So cost of fertilizer is reducing, is decreasing for the farmers. To that extent, farmers are saving some money. And also there is some focus on climate change in terms of monitoring, modeling, and networking. Because in this component, Ministry of Agriculture identified certain institutions like ICAR, outside ICAR also. ICAR stands for Indian Council of Agriculture Research, where they are trying to model what is going to happen in terms of climate change, productivity, the modeling, networking, and all these things. And we are also trying to, as I said, the government of India is committed to INDC's intended nationally determined contributions in terms of our mitigation goals. So we have pledged that 30 to 35% emissions will be cut by 2030. So this is our commitment, and I think we are achieving that part of the commitment. So there is very visible progress in terms of this is not a sector-specific goal, but country as a whole, economy as a whole. So fortunately, agriculture doesn't have a sector-specific goals in terms of reduction in emissions. Though we are voluntarily trying to reduce emissions from agriculture, but in terms of international commitments, global commitments to UNFCCC, we did not commit any reduction in emission levels as far as agriculture is concerned. So within NMSCA, there is one specific project called NICRA. Many people, some of you might have heard about it. This is actually National Innovations in Climate Resilient Agriculture. This is the project being run by the Indian Council of Agriculture Research for the last about 12-13 years. It started in 2011. So far, the government of India spent on this project about 40 crores. This project is unique in the sense that it is a multi-institutional, multi-sectoral project where many ICAR institutes actually, just to bring to your notice, Indian Council of Agriculture is organized in terms of 8 divisions. There are 8 divisions. One division is specifically for crop production, crop sciences, that is called crop sciences, where crops like rice, millets, or cereals, millets, production of these crops is engaged. Most of the research goes into that part. Similarly, there is another division called animal husbandry, where the research needs of livestock sector are addressed. And there is another division called fisheries division, where the research and extension needs of fisheries are there. So likewise, there are 8 missions. One of the missions, 8 divisions. One of the division, the other division is the natural resource management division, where more focus is on soil management, land management, water management, climate management. So this project is actually draws together all the institutes under these 8 divisions, including the extension division. There is an extension division where all the KVGACs are supervised, monitored, and administered. So this project kind of cross-division, cross-cutting in terms of sectors. So this project is being handled at the ICR level by the Natural Resource Management Division. At the institute level, KRIDA is actually hosting this project. So we are actually coordinating. KRIDA stands for Central Research Institute for Dryland Agriculture. This is in Hyderabad. So we are coordinating this project, and this project has 3 major components. One is strategic research in terms of research needs when the climate change is going to happen, in terms of temperature rise, in terms of rainfall distribution changes, in terms of heat waves, cold waves, in terms of sea level rise in the coastal districts. So what are the research needs actually? So in terms of developing suitable varieties, in terms of management, crop management, in terms of economic management, in terms of any other kind of climate forecasting, agro-advisory services. So how to do strategic research needs. This is one component. In this component, about 40 institutes are doing some kind of research across the country, both in terms of crop, livestock, fisheries, economics, extension, everything. Everybody is involved in this. And there is another component which is actually a phase of this project. That is called technology demonstration component, where what we are trying to do is that because this agriculture research system we broadly refer to as NARS, National Agriculture Research and Extension System, NARES. So this system is in place for the last 70 to 80 years, and they are developing technologies like improved crop varieties, high yielding varieties, fertilizer management, recommendations on fertilizer management, pest management, everything. So there are some components which are already proven to be helpful in dealing with climate change and climate variability. So what we are trying to do that without losing much time. So we are identifying those technologies or varieties, anything that we are trying to take to the farmers so that they get exposed to these technologies and they adopt on a larger scale. So this is this part we are implementing this in 150 districts in the country. In each district, we are working in a cluster of villages, 4 or 5 villages. So we are trying to expose the farmers to this kind of technologies. And in this project, we are also looking at the impacts, possible impacts again. Some of the impacts I already told in terms of productivity changes. income changes, calorie consumption changes. You can see here what is likely to happen in terms of milk, rice production, wheat production, mustard production. You can see the graphs, maps here, changes in here. So as you grow from yellow to reddish, the impacts are more. You can see the granular spatial scale also. You can see the impacts are more in Maharashtra, parts of Uttar Pradesh, Northeast. Similarly, for wheat, you can see the impacts are more in southern part of Maharashtra, eastern parts of the country, Orissa and West Bengal. Mustard also, Gujarat, the impacts. You can see the milk production changes here. Milk, 1.8 million tons of production of milk is likely to be lost. There is 2%, almost 2% of production in the country. Similarly, there are production losses, marine fish availability, and the breeding behavior of Indian crops. This is one again. So even the insect pests, the incidence of insect pests is also likely to change and different. Here, the broadly what happens is that because of high temperature and also higher levels of carbon dioxide, there is something called in somebody with agriculture background will understand CN ratio, the ratio of carbon to nitrogen in soils. So when the CN ratio increases, that will lead to actually reduction of when the carbon dioxide levels increase, that will lead to reduction in CN ratio, the ratio of carbon to nitrogen. So when the ratio increases, what happens is that the nitrogen concentration decreases in the plant pots. So when the nitrogen concentration decreases, that means actually a dilution of proteins. So suppose if you to get, say, 1 gram of protein without climate change, if you assume that 10% of the plant product contains protein, so if you take 100 grams of plant product, so the insect gets 10 grams of protein. But when there is a dilution of protein, say from 10% to 5%, to get the same 10 grams of protein, the insect has to eat 200 grams of plant parts. So this is what happens actually. That means the insects have to eat more of plant product, plant leaves or succulent parts of the plant. So that is the problem. The other problem is that when the temperature is rising, the duration of the larvae, they get shortened. So because larvae, because you know that insect has 4 different stages, egg, larva, pupa, and adult. The larvae are the stages of insects that are more harmful to crop plants, because those are because it is the larvae that eat plant parts. So the larval duration actually gets shortened because of high temperature. Because of this, in a plant duration, the number of generations of larvae will increase. That's why the incidence of insect pests is going to increase in the future because of climate change. And we are investing a lot in research infrastructure because we want to understand the future, how the plants respond to climate in future. So we have to mimic the conditions of future climate. So there are certain, I don't go into the details. So these are some of the facilities where the future climate can be mimicked. We grow these crop plants in these mimicked climate conditions. And we see how the plants behave, how the crop plants behave, how the insects behave. So these kind of facilities are supported in this project called NICRA. So these facilities, these are very high cost intensive facilities, crores of rupees of investment in this. This investment is going on in KRIDA in Hyderabad. There's a place called Baramati near Pune. There we invested in case of these facilities. In ICAR, Delhi. Similarly, in Meghalaya, we have a center in northeastern Shillong, near Shillong. Similarly, in Bangalore, there is Indian Institute of Horticulture Research. So, at different parts of the country, we are creating this kind of facilities, and we are trying to understand. We are trying to develop deep understanding of how croplands, animal species respond to changing carbon dioxide or changing temperature regimes. And one of the issues in terms of addressing climate change is that we have to identify the regions, because India is a huge country with huge diversity. And we are developing countries. Even for the developed countries also, resources are always limited compared to the needs. So we don't have unlimited resources to address any problem. So we have to prioritize where to invest our money or resources. Which brings to the question that which are the regions where the climate change risk is likely to be more compared to other regions. Again, as I said, district is a development unit, administrative unit for us. So we are trying to do this analysis in terms of climate change risk assessment. Sorry, I missed that slide. Here, climate change risk is actually a function of three components. One is exposure. Exposure is nothing but who is getting exposed to climate change. What is getting exposed to climate change in terms of how much crop area is getting exposed, how many number of farmers, what is the population getting exposed, what is the size of population getting exposed to climate change. So this is exposure. And vulnerability, the other dimension is vulnerability. Vulnerability is how weak or strong you are in terms of your ability to respond or to withstand to changing climate. So this is again a function of your kind of physical, mental, financial, technological health. So that is nothing but your capacity to invest, your capacity to understand and respond, and your capacity to protect yourself. So basically, that brings down to kind of things like education, literacy, market access, irrigation. Irrigation is very, very important in agriculture. So the climate is very hot. If you can irrigate the crop, you can save the crop. Similarly, if your soils are good, deep, and fine, still the crop will not suffer so much, even if there is a dry spell or rainless period. So this is a kind of vulnerability. This is what is meant by vulnerability. And also hazard. Hazard is nothing but climate variability or climate change. So in terms of incidents of drought, flood, drought, dry spell, temperature rise, reduction in rainfall, increasing in heat wave. So we're kind of quantifying this. I'm not going to the details, but that it itself becomes a lecture. So I'm not going to say. So you can see the distribution of where the you can see here all the brown, the light brown and dark brown districts. You can see in the UP, some parts of Haryana, all these brown, light brown and brown districts in the central part of the country. Here the exposure is high. Similarly, vulnerability is high in northwestern parts, some parts of the eastern country. Central India, you can see vulnerability is high here. And you can see historical hazard. So for the last 40 years, so what is the hazard? You can see here all the coastal districts, because these coastal districts are exposed to both flood and cyclone. And on the west coast, some of the districts on the west coast, especially in Gujarat, they are suffering from both cyclone as well as drought. So because of these problems, you can see the hazard incidents, especially historical hazard, is more in western parts of the country and the eastern parts of the country. And future hazard is going to what the climate, projected climate during this period, 2020 to 2049. This is the average climate during these 30 years. This is a kind of projections. You can see climate is going to be hazardous and most unfavorable in this dark brown color districts, especially eastern part of the country, northeastern part of the country. And if you combine all these four, exposure, vulnerability, historical hazard, and future hazard, so what you get is actually this map. This is kind of a climate risk. You can see the climate risk is very high in parts of Rajasthan, hill states of Uttarakhand, Jammu and Kashmir, Himachal Pradesh, and also northeastern parts, and some districts in Kerala. But the reasons are not the same for the high climate change risk. You can see here, you can see in this map, you can see what is leading to this high climate change risk. You can see the pinkish or magenta color. There, the exposure is actually leading to more risk. Exposure means more population density, more small and marginal farmers, more agriculture area. You can see here parts of Pradesh, UP, Bihar. These are the places, the states where the population density is very, very high. Similarly in Kerala. So here the problem is how to handle it, because it is not easy to reduce exposure overnight. So they take very long time measures. Similarly, what is a safer, better way of dealing with reducing climate change risk is reducing vulnerability. You can see this gray color, light gray color, in Rajasthan, Maharashtra, parts of southern Andhra Pradesh, in Tamil Nadu and Karnataka, you can see, and also in Chhattisgarh also. You can see these districts where the vulnerability is high. As I said, vulnerability is linked to the irrigation, soil health, fertilizer use, or technology adoption in agriculture, literacy, access to knowledge, access to markets. So these are some of the factors that respond to policy and development interventions. So this is a more or wiser way of reducing climate change. So we have to act more in those districts where the vulnerability is high. Not that we should not act in other districts, but there the response time will be very long. So very, very difficult to bring changes where the climate change risk is due to high effect. And where the hazard is high, like some of the districts in Kerala, northern parts of Madhya Pradesh, Bundelkhand region, Uttar Pradesh. So this dark brown color or pinkish brown color, the hazard is going to high. So there we have to expect that the benefits of mitigation will accrue as soon as possible. So you need stronger mitigation efforts to reduce the impacts of climate change in those. But to that time, since the mitigation takes a long time, we have to invest in adaptation also. Then what are the technologies that are already available, that are already being taken to the farmers in this project? So you can see, I can list some of the projects here. Zero tillage, because that enables early sowing in wheat especially. Irrigation, fertilizer management, heat or drought tolerant varieties. So these technologies can lead to 10% increase in yield. Similarly, leaf color charts, fertilizer management, direct cereal rice, resilient varieties, they need to up to 18% increase in crop yields. And raised bed planting, resilient hybrids. So in various crops, these are the probable impacts of climate change, but adoption of these technologies will help reduce the yield losses. As I said, we are working in 150 districts where the climate change risk is high in these districts. You can see these districts here, the prominent problem in terms of climate change. You can see the legend here. Some of the districts where the drought is more problem. Some of the districts flood is problem. And some districts, both the drought, flood, and a combination of hazards are there. So these are the places where we are working in. So we are working currently in, we are trying to promote to 350 technologies, 446 villages. These districts cover about 200,000 hectares. So from nearly 1.8 lakh households are covered in this project. So these technologies actually, as I said, this is cross-sectoral intervention. So what we are trying to do is that we are trying to group these technologies into 4 modules: crop production, natural resource management production, livestock production, and also support systems. Because institutions are also, because these are the technologies, these 3 groups of technology, but to enable adoption of these technologies, we need some kind of institutional support. That also we are trying to promote in terms of custom hiring centers, seed and fodder bank systems. In each way of those 150 districts where we are working through KVGAC, we established an institution. I will come in the next slide. So in each module, there are different technologies: integrated farming systems, resilient cropping systems, improved varieties, better crops like shifting to millets. Similarly, in NRM, we have technologies for soil health management, carbon sequestration, rainwater harvesting like farm ponds, those kind of technologies. In situ moisture conservation like broadbed furrow, raised bed furrow, conservation furrow, and feed and livestock, feed management, fodder management, shelter management. These are the technologies that we are trying to promote. So we are trying to reach farmers through different mobile apps. Digital tools are also there, not number of there. We are trying to take this information, knowledge, the farmers through a number of these tools. So these are the institutions that we are trying to create, nurture, and develop, so that all those technologies in crop production, livestock production, water management technologies can be adopted. So in each village, we established what are called village climate risk management committees. This is a kind of a representative body of farmers. Some 15-20 farmer members will be there. They are drawn from small marginal farmers, also different social strata like SC, ST, and also 1 or 2 members of the Panchayat Raj, like village Panchayat, and also facilitated by KVK also. So where what they do is that to support the project, they identify the spots or sites where different technologies are to be, especially NRM technologies are to be created, like check dams, compounds are to be created. They also identify the farmers, households who need support in terms of providing technology benefits. Like if you want to promote, give some seed of variety, some improved crop variety, they will identify. That committee will identify rather than KVK identifies in isolation, so that the acceptance of the technology will be better. So on one way, they're helping the KVKs to identify. Also on the other way, they're helping better uptake of the farmers by the farmers. Similarly, custom hiring centers of farm machinery. What we are trying to do is that we are identifying some of the machinery which are appropriate and needed in that village and the villages. We are investing in purchasing those machines and making available those machines on a hiring basis. And this VCRMC, Village Climate Risk Management Committee, that they will run this custom hiring center. They will collect some hiring charges, and that will be used for repair and maintenance of that those machines. And seed production, farmer production system. We are trying to produce some seed of the climate resilient varieties, drought resilient varieties. So make a stock of it. When some farmers want to adopt both that kind of variety, they will try to provide that variety to the farmers. So these are the kind of institutions that we are trying to create and promote, so that the actual technologies can be adapted better. Because even if the seed is there, if these support systems are not there, farmers are aware also, then we cannot expect the adoption of those technologies. What are the benefits? What are the whether these projects are actually yielding results or not? So we, as I said, we spent more than 850 crores over last 13 years, whether they are leading to that kind of benefit. You can see one mitigation benefit they try to quantify. You can see there is better carbon balance. That means we are capturing more carbon compared to earlier. So there is already mitigation benefits are already there. You can see the numbers here. I'm not spelling out the numbers. You can see here. Similarly, yield and income gains here. You can see 12 to 13% more yield and more income to the farmers where this technology, this project is under implementation compared to those who are not. This is a routine work where we are trying to document these experiences and knowledge in various both print and mobile apps already I told with the digital media. Through print media also, we are trying to take these technologies both in terms of research publications, also the documents which are actually more stakeholder friendly to the governments, state departments of agriculture. So we are trying to document this so that we are everything is available in this website. You can just Google NICRA, that will lead to the web page of NICRA. All these are available on the web page. You can see some of the benefits, both in terms of carbon sequestration as in the capacity building also happening. And you can see this experience of NICRA, which KRIDA was first to start, ICR was first to start. Now some of the state governments, like some of you might have heard about POCRA, Project on Climate Resilient Agriculture. They took this model of ICRA. They are trying to work in 5,000 villages in Maharashtra. This project is supported by World Bank. Now they are trying to, first phase is almost complete, and they are trying to start the second phase. So the model is very similar to what we did in ICRA. There are some add-on, like they are also giving focus on FPOs, which we are not doing in ICRA. But in POCRA, they are also involving the farmer producer organizations also to take this thing forward. And there is also South Asia initiative on Sea Success, where some models of this project is funded by Asian Development Bank. This is a small scale project across South Asia, $1.5 billion. And the governments of Bihar, the government of Tamil Nadu is now starting a project on climate resilient villages. Government of Odisha has already started, Madhya Pradesh already started, and also Jammu and Kashmir, they all started. So they're adopting this kind of model. But one typical challenge for us is actually, as I said, India is a country dominated by small farmers, not marginal farmers. If you look at these adaptation options, on the first column, you can see planting time adjustment, change varieties, on-farm diversification, off-farm diversification. So these are the typical adaptation options. These are the requirements. Access to information. If you want planting time adjustment, you can see, because timely sowing is very, very important to offset the damage lost by climate change or climate variability. So for that, we have to have access to information. And for timely sowing, we have to have proper sowing machines or sowing implements. So this is the key requirement. But small farmers cannot have access to information. They cannot buy the implement. So it's in most of these technologies, the small and marginal farmers are not better placed. This is another challenge that as a government, as a society, as a non-government sector, as a private sector, we have to address. So I'll skip this, already covered. Other than the NMSA, there are numerous government schemes. I give a sample of them here, not all. What I try to do is that there are a number of technologies that are relevant for climate change adaptation, like farm ponds, community farm tanks, check dams, land shaping, broadband for row. And there are also different development schemes and programs of the government of India. So these are the development schemes of the government of India, where this particular technology can be accommodated. Suppose if you are an NGO or a private sector agency, if you want to promote farm ponds, so these are the programs like MGNRAGS, Pradhan Mantri Krishi Sinchai Yojana, NMSA, MID, Micro, this is Mission on Integrated Development of Horticulture, MIDH. So these are the schemes that you can look where the subsidy component or other support you can expect from. If you are working in a village, you can liaison with the agriculture department there. You can take the support from these schemes to promote these technologies. Similarly, if you want to promote region follower method, only NFS, National Food Security Mission, and special mission on submission on agriculture machinery. This is another project. This is mechanization. So these are the projects. So this is again, you can see the document here. There, the long list is provided of both the development schemes as well as the technologies where each technology can be supported. So if you are working in the extension or development problem where we are trying to develop a particular technology, you can get an idea of this. This I will skip. Again, there are barriers to adaptation. Whatever you do, so you can see we did a study in different parts of the country. You can see basic adaptation basic barriers are inadequate availability of improved seeds. Like I'm telling that improved seeds are tolerant variety, crop variety. They are very critical for climate change adaptation. But availability is a key constraint there. Similarly, irrigation is another key constraint because we talk about drought, we talk about dry spell, we talk about temperature or high temperature stress, heat stress. Irrigation is the solution. So without irrigation, it's very difficult. So access to irrigation is very critical. And knowledge, again, I said it's very critical. And climate change is very knowledge at the scale where farmers require. We have very reliable knowledge at the India country scale, at the global scale, we have very reliable projections. But as you go down to the village scale or district scale, the projections are somewhat uncertain. Lot of the likelihood of realizing those projections is somewhat less compared to the scale, say, state or country. So still there is some hard science research needs there in terms of climate, understanding climate models, developing climate models, because they are very, very intricate and climate, global linked models are there. How the ocean systems, atmospheric systems and earth systems are linked. So very, very complex, very, very, but one thing is that India is not much behind compared to other countries, especially in forecasting of our monsoon. India, the capability of IMD, the capability of Indian Institute of Tropical Meteorology at Pune, they are no less than the global institutions in terms of because Indian monsoon is one of the most difficult monsoon systems, weather systems to project or predict. Other monsoon systems, other climate systems are relatively easier to forecast, but not the Indian monsoon. This is another study where what actually farmers are expecting from the government to deal with flood or drought. This is with respect to drought. So what they are, these are farmers' expectations, not that our research. So in terms of technology, what these are in different parts of the country. You can look, if you look at, say, for example, for technology, what farmers are expecting from the government is that support in terms of both investment, subsidy, or technological support, and knowledge support, land development, rainwater harvesting, improved irrigation methods like micro irrigation, sprinkler, drip, organic manures, drought-resistant varieties. So similarly for the infrastructure, they want more irrigation infrastructure like groundwater, and policy, timely and easy access to input markets, capacity building policy, and support SHGs, credit access, insurance. So you can in different dimensions what farmers are expecting from the government. This is for flood. I don't want to. And finally, what I want to conclude with is, I think I exceeded my time already. What we have to, in terms, if you want to deal with climate change, what we have to do is there should be a cohesive play between those who are involved in technology development, like Indian Council of Agriculture Research, state agricultural universities, and also departments of agriculture of both state governments as well as the government of India, their institutions, investments and policies. They have to work in tandem with one another. Only then the climate change adaptation can be taken forward. And one another type is that I have to mention NABARD, the role of NABARD here, because there are a lot of money coming from international organizations like Asian Development Bank, IPC, UNFCCC. There are two particular funds called Adaptation Fund and Green Climate Fund. These two, for these two particular funds, NABARD is handling. NABARD is a national implementing entity. You know NABARD is, right? What NABARD is? National Bank for Agriculture and Rural Development. They host this fund and they will invite projects on a large scale. They don't take projects of 10 lakhs or 20 lakhs. They take projects of $1 million kind of thing, investment. So that projects have to be broad-based. They should run across states. Big institutions should come. Support adaptation of money they are handling. But similarly, other than these two international funds, there is also funded by Government of India. About 100 crores fund is given to NABARD. That is called National Adaptation Fund. So through that also, NABARD is supporting various adaptation funds. Already many state governments are trying to access these funds where they want to handle the climate issue of climate change on a broader scale. So this is where I will stop. Any questions, comments? I'm sorry that I exceeded time. Shall I share, sir?
Yeah. Thank you so much, sir. Wonderful presentation. You're having a great knowledge in the field of climate change in India agriculture. We explained very well about the climate change on crop. You explained very well about the climate change on livestock, temperature in the various states, location, their differences, possible mitigation practices, right? So thank you to our today's esteemed speaker, Dr. C. A. Ramarao, for sharing your valuable insights and expertise during our online KVDialogue 18. Your knowledge has enlightened us and inspired us to think critically and act purposefully. We are grateful for your time and dedication in helping us expand our understanding. Your contribution has truly enriched our virtual gathering. So thank you so much, sir, for today your presence. Thank you so much, sir. Sir, now we take the questions from our today's joiners. So I request to the delegates who have joined online, if you have anyone having the questions, so please text in the chat box. If there is no question, so sir, I having question. Can I ask?
Please.
The European Union, they're continuously blame on the indigenous cows. They emit more methane as comparison with the exotic cows. So what kind of the mitigation practices just we followed or just you suggest to our Indian farmers to mitigate or to minimize the methane production?
There are some technologies actually for mitigation, reducing greenhouse emissions. There is some feed management technology. There are some feed composition developed by the National Dairy Research Institute, and also in Thanuvas, there is an institute in Tamil Nadu, and also in Bangalore, there is an institute called the National Institute of Animal Nutrition and Physiology. They formulate certain feed components for the livestock. If you feed those livestock with those feed, I am not getting the names of those formulations. There is some effect on reducing the emissions of methane.
Yes, sir.
Similarly, there is also some. There is one thing, mitigation, but also for animal health is also important. When you are exposing animal to the high temperature, animal health itself gets affected, right? So
Yes,
there are
sir.
also they're trying experiments with different kinds of material used for animal sheds, especially in Northeast, in Rajasthan. They are using different material for constructing animal sheds, where the heat stress on the animal is reduced. To that extent, the productivity of animal is increasing. So, especially in livestock, there is something called THI, thermal heat index. THI, right? And temperature heat index.
Temperature humidity index, THI.
Humidity
Yes,
index, sorry.
yeah.
So that
So
is
thank you.
very, very critical for determinant of milk productivity. So this, if the THI increases more than 80 or 85, that actually affects milk productivity a lot. So if the better fodder management with better feed management with shelter management, and also breed management, that's a kind of long-term intervention. So there is evidence that we can reduce the ill effects of THI.
Yes, sir. As you discuss about the ruminants also, the effect from the temperature humidity index or the climate change. The
Yeah.
poultry birds also, they comes under the histories in the
Yes,
summers, the rising the temperature.
poultry,
Already
similar also there in poultry, especially in Hyderabad, there is an institute called Directorate of Poultry, is DPR. So they developed one mineral mixture. So that will reduce the THI impact as well as it protects from heat stress. So there are also some private companies which are also coming out with different mineral mixtures that are fed to poultry. So that they have noticeable protection from heat stress.
okay. Thank you, sir. Thank you so much for your presence with us today. So there is, I think, no questions from the other people here online platform. So thank you so much, sir. Definitely, we need continual support in future also from your side. Thank you so much.
Thank you very much. Thank you, KhetiValah. We wish you the best of luck in your efforts to take the interest of farmers.